The first step in a hydroboration oxidation mechanism is the hydroboration part. To start off, you have a borane molecule, which is going to act as our electrophile in this case, due to its incomplete octet. And we will have an alkene, which in this case is propene. And this will act as the nucleophile due to its pi bond. So the pi bond on the alkene will attack the empty p orbital on the borane molecule. Borane has an sp2 configuration and has 3 bonds right now, but it has an open p orbital, so it can still do this. So here we have the pi bond attacking the electrophilic boron, and then when this occurs, there's a simultaneous hydride shift where one of the hydrogens attached to the borane molecule will jump to the more substituted carbon on the alkene. This is what we call a concerted reaction because these two steps happen essentially simultaneously. And because these two parts react simultaneously, the stereochemistry for this reaction is always a syn reaction, meaning that the boron and the hydrogen will both attach to carbons on the same side. And in this situation, another interesting thing to note is that the boron attaches to the less hydrogen or the less substituted carbon, which makes this an anti-Markovnikov reaction, as you can see here. This reaction can occur 2 additional times with 3 total alkene molecules. As you can see here, the pi bond once again attacks the empty p orbital on the boron, while the hydrogen has a simultaneous hydride shift, and this happens 1 more additional time. And the end product is a trialkyl borane, which will be used for the oxidation part of this mechanism.
For the second part of this reaction, we use the bottom half of our reactants: peroxide, hydroxide, and water. Our oxidation starts with the electron lone pair on the oxygen going toward leaving this sigma bond and placing a charge on an oxygen atom, resulting in these 2 products right here. Then, using our product from hydroboration, another reaction ensues where the sp2 boron can take on another bond here, resulting in this larger product. In an alternative view of this 3-carbon chain, we see a shift towards this oxygen and then a cleaving of this OH, as seen right here, creating a hydroxide ion, which then attacks the other sp2 boron. As a result, the boron now has 4 bonds, which then results in a shift of electrons, cleaving this 4-carbon chain with an oxygen and a charge of -1. In our final step, our 3-carbon chain and water interact, using electrons, a lone pair of electrons on the oxygen, contribute to this H, cleaving this OH, resulting in a final product: 3 carbons, and alcohol on the less substituted part, which is anti-Markovnikov syn addition product right here.